I have a great pleasure to welcome you on the last presentation for today, on the last session, what it takes to process healthcare data. My name is Piotr Kaczor. I'm happy to be your host today. I'm an IT architect with around 20 years of experience in the IT industry. I've worked for various branches or various sectors before. So I started with some telecom, then I switched over to the retailing companies. I worked a bit for the pharmaceutical ones, and I ended up right now in the healthcare industry. And for the past 10 years, I've been working with the healthcare data, and I will try to summarize some of my experiences here for you. So what we'll be talking about? I'll start with a short introduction to IQVIA. Then I'll follow with generally what it takes to process lots of data. I'll be talking both about the volume of the data, which is natural, but also about the variety of the data, which all constitutes big data topic, because healthcare data is actually big data. Then I'll switch to the data complexity part. I will talk a bit about the multidimensional aspect of the data we are processing. Then data privacy, so all the regulations. It's either introduced by the law or by the local agreements, plus the risk of re-identification, even though we are following the guidelines from the law or from our agreements. It will be followed by the data supplier agreement discussion, so things about the ownership, about the input format, about the CDC, how exactly do we feed the data into our systems. Finally, I will focus on the data dictionaries, both on the ownership and the interoperability of the data dictionaries we are using in IQVIA. So, starting with that, I would like everyone here to raise your hand who has heard about IQVIA before. Okay, it's around 5-6 people, which means probably it's very good for me to be in front of you. So I'll try to explain it to you because it's very easy. IQVIA is a company that actually processes lots of medical data, lots of healthcare data. It all starts with the patients and the patient interaction with the physicians. So everything that happens between you and the physician within a given either practice or a pharmacy, every single action, so the electronic medical records, so everything surrounding your patient visit, your medical tests, your problems that you're reporting to the doctor, your diagnosis that you're receiving, any kind of claims you may be having against the doctor or against an institution that made those services to you. It could be, as I said, all the laboratory data. It could be all the medical devices you're wearing and all the information that they collect. It could be various patient registries. It could be the prescriptions you're receiving from a doctor. But it's also about all your interactions with all the healthcare institutions. So I mentioned claims before, but it will also be any clinical trials, any researches, or any sales, so purchases of the drugs, etc. It's generally everything related to your healthcare. IQVIA is also a company that has its offices in more than 100 countries around the world. We are processing really huge volumes of the data, so it's around 600 million non-identified patient records, around 1 million data feeds that we are dealing with, around 140,000 data suppliers that we are taking and processing within those systems. So I promised that we will start with talking about big data. So anyone has any clue what would it mean to have lots of data? How big is the data to consider it big data, first of all? And for those who are actually volunteering, I still have some Spoina conference tickets. There are also the cups with IQVIA logo, or if you prefer, the Confitura ones. So anyone would make a shot on how big the data needs to be to call it big data? Yeah. It depends, yeah. Depends. Okay, I will use a simple term in here. So for me, big data starts in the moment that the data doesn't fit your own laptop. So these days, it's a couple of terabytes of data that you can probably squeeze into your laptop and you can safely process on your laptop. It will be good enough to process this volume of data. Once you grow over this volume of data, that's where big data starts. And that's where all the big data complexities come into play. So what it takes to process this bigger than couple of terabyte volume of data. So I noted down a couple of points, and I would like to refer to them. First of all, scale. So it's important, as the volume of the data grows, it's important for your infrastructure to have an ability to scale. It's both about the storage, but it's also about keeping the same response time the more data you have. So the data increases, but you would like to have a flat or even decreasing response time for your applications. At the same time, you want your infrastructure to be able to shrink because your cost is growing the higher you go. And there are obviously some periods when you're not using that infrastructure. So in a moment you're not using the infrastructure should somehow collapse or slow down or consume less resources so that at the end it's less costful for your application. Obviously the cloud these days addresses those two the best. But even if you're thinking about the on-prem, you always think about the response time versus the cost it would take. Then lots of data also means it requires a lot of domain knowledge from you. So I mentioned that it's not only a huge volume of data, but it's also a huge variety of data. Because of this variety, you need to have some domain experts that will be able to explain the different kinds of data you're processing, how they all interact with each other. So you need a lot of domain knowledge. And obviously, to process the data within a given response time and at a lower cost, you need a lot of technical skills. And the performance really matters the moment that the data grows beyond a couple of terabytes. The next thing is the cost. It's a bit harder to predict, especially if you go to the cloud. Because you really need to rely on your users, how often do they use it. So if they would be consuming your data every single day, 24 hours a day, the costs would grow. There could be periods where the costs are just enormous. There will be other periods where the costs are much lower. So it varies at times. There are some load peaks. It's just harder to predict and harder to estimate. Finally, the integration. So as I mentioned, it's a huge variety of data. You're having many sources coming. The data will be coming from many systems. You will need to identify at some point in time what's your master data. So you could be having the data dictionaries from one place, from another place, from a third place. You need to identify which one of them is telling you the truth. If a record doesn't exist in one of them, you need to identify to which system to add it and which one will become your master data system. Or you need to somehow consolidate multiple systems to tell you actually whether a given, I don't know, practice, let's say, or a drug, or a laboratory test, whether it exists. And the last thing is the data quality. So your data, because we are talking about billions of records, you can imagine that the more data you have, the greater the chance is that every single second hundreds or thousands or millions of records are being produced to your database. You need to be able to consume that. So forget about all the techniques that you had before, that you can actually clean up all your data warehouse, let's say rebuild the entire application. You need to be constantly upgrading this software, and you need to live with the fact that the data is being ingested into your system every single second. So the data is constantly changing. More than that, the sample test data is not easy to get. Generally, the test data is not easy to get. So if you want to get a full representation of your production data, copy it over into your test environment. In most cases, your test environment is not fit enough to take this volume of data. So you need to start sampling. Sometimes, because of the data privacy regulations, which I will be mentioning later, you will also need to make sure that your test data is auto-generated. You cannot use the same data as it is in production. So that's yet another layer of complexity. Here I'm showing you the data complexity because I mentioned this data is complex, right? So first, just to name what will I be talking about when I talk about the medical data. I mentioned the patient visit within a medical staff or a doctor office. A patient is reporting a problem. A doctor is reacting to that problems raised by the patient. He's actually giving you a diagnosis. He may refer you to a different clinic, or he may simply write a laboratory test or ask you to take a laboratory test, write you a prescription if the drugs are already there for your type of illness, or give you an immunization or prescribe you an immunization so that you can be injected, right? All of that is various facts. But if you look at the various industries, it's not a new thing, right? Even in financial sector or in the telecom sector or in the retailer sector, very often you have lots of different facts, very different systems, I don't know, billing system, CDRs, the call detail records, some kind of sales systems, right? There are always many facts. The thing in here is that the complexity of this data comes in the relationships between all those facts. And the reason why it is so complex is all those facts actually happen during one single visit in a doctor's office. And then you need to preserve all that data and you need to process all that data together, having all these relations between them. It's not so easy to digest the data, to ingest the data into the system. Typically these days the systems are looking for something called eventual consistency because as you know, when you work with big data, you don't have like foreign keys or validations whether I don't know, a diagnosis for a given problem already exists when I'm loading a diagnosis. So you would need to do all the checks to make sure that your data is eventually consistent and somehow feed it into the system and then process also, which requires a lot of joins between the data. Now, in terms of the industry regulations, so starting with the laws, so obviously the GDPR, Global Data Protection Rights, the Health Insurance Portability and Accountability, that's an American HIPAA agreements. There is obviously a Polish law, that's RODO. There will be also...
RODO to nie jest polskie przepis, tylko to jest GDPR po polsku.
Yeah, that's an adoption of GDPR. Yeah, sorry, if not everyone heard. GDPR in Poland is RODO.
Separate act adopted in Poland. So in fact we have two acts.
Yes.
RODO/GDPR and the local.
Yes, correct. It's all the different flavors, right? So it could be international law. It could also be country-specific law that we need to adjust to our systems. Plus, there are also various international laws that like Human Rights Act or Patient Rights Act and the other acts, which also have some corresponding laws within Polish law system. Right? So that's the first thing we need to comply with. Then it's the various agreements. It's either the agreements around the data locality. So some countries are just deciding that my data cannot leave my country, especially the data about the healthcare of my citizens. So there will be some privacy laws that are related to the data locality. And there could also be some agreements being made that, so sometimes it could be the law, sometimes it could simply be an agreement with a supplier. And we had a situation with our supplier in Australia, for example, that said, your data cannot leave Australia. It's not because it's written by the law, but if we are going to sign a contract with you, this data cannot leave Australia. So simply because of that, it's not necessarily a law that says so, but it could be our suppliers that are telling us this. There are also different data purposes. As you know, under the GDPR, whenever you're consuming some data, you need to tell your customers that we will be processing your data in this or that purpose. And the purpose could be we will be running a national level studies trying to summarize the let's say that the amount of diseases or the drugs that are being prescribed for a certain disease in a given country, right? So we could be doing some national level studies. But the same data doesn't really fit when we tell to our customer, you know what, we'll be giving you a feedback about your patient. So for example, the customer is a practice, we'll give you a feedback about your patients which are in an immediate need of a reaction from you. That's a different purpose. We are not anonymizing that data. It's going to be not anonymized. And if it's not anonymized, that simply means it needs to be stored differently. There are different regulations because of that. So even the same data, we could be loading in or storing on our side in two different spaces. And finally, to complement that, there is IQVIA Code of Conduct. So there are some both company ethics and additional assessments that we perform within IQVIA to make sure that your data is safe with us, and that whenever we are working with an anonymized data, we truly anonymize this data. So just about to understand the last point a bit better, I just wanted to switch our discussion to the privacy impact assessment. Do you know what the privacy impact assessment means, and have you already performed one in your company? Okay. Anyone? No? Okay. So the privacy impact assessment is, imagine you already have an anonymized data that you receive from your supplier. You need to assess what's the chance of reestablishing the identity of an anonymized person. So judging by the attributes you already have, even though they are technically anonymized, the patient doesn't have a first name, surname, etc., there could be some other attributes that could result in re-identifying the patient. And I'll give you a couple of examples of those. So imagine that you loaded all your data, you have a year of birth and a gender. That's the only two attributes that you retain for a given patient. And you would like to check if your data is secure. So apparently the year of birth and gender normally give you a pretty good anonymization. However, your age could be a problem. Because we are all, let's say, in our 20s, 30s, 40s, 50s. But what if your age reaches 100 and beyond? What if you become an elder person and suddenly you're a single person in a given region that has that age? Well, suddenly if I would store within a database your year of birth, that would be telling me you were born in 1901, let's say. That means you're 22 years old, and that means you could be a single person. And that means your data becomes re-identifiable. So we need to secure our systems for that. The next thing is the drugs you take. So again, normally we are taking simple things like, I don't know, paracetamol when our head is hurting. Or whenever we have a stomachache, we take some other drugs for that, right? But these are typical illnesses that don't really make us identifiable. But what if we have a illness or disease that is fairly unique within a country? That only we are taking specific drugs for it, that we are sometimes ordering or purchasing those drugs in a special way. Well, suddenly the drugs that we are taking also make us vulnerable for the re-identification. So we need to make special precautions not to allow anyone to guess your identity. And finally, surprisingly, it's the contracts we are signing. I will be talking a bit more about the data suppliers in a moment, but generally, we sign a contract with the practices. And if we sign the contract with majority of the practices in a given region, this is not a problem. But if our coverage would drop, and we would suddenly sign a contract with just one practice in a given region, and your reporting apparently numbers are reflecting that region, you would be able to identify a practice. And obviously from identifying a practice, it's just one step to identifying the patients that are actually going to those practices. So we are not only trying to protect your identity, but also the identity of the doctor or the identity of the practice that you're attending to. That way you could be 100% safe that your data is safe with us. And this kind of privacy impact analysis we are performing on all the data assets we have in IQVIA. Now let's take a look at our onboarding or the ingestion process. So on this beautiful funnel, I wrote down the 3 points which largely describe the issues that we face from the data ingestion side. So starting from the top, that would be the ownership of the data. I already kind of mentioned it slightly that not all our data is ours. Actually, very tiny portion of data that we are processing is ours. It's never 100%. We are usually purchasing that data. That means, from one hand side, all the data we are acquiring, we are very much concerned about its quality. But unlike every other market sector where the quality matters obviously as much as ours, you don't typically reject the bad quality data. In our case, we are saying if the data is not good from a given practice, better reject it. Better don't take it into account. Why? Because we know anyway that we haven't signed a contract with 100% of practices in a given region. So if we don't have 100%, we need to project. It's a hard word. It's more or less like expand or extrapolate, but it basically means that we need to find some way of statistically expanding the data from the practices we have signed a contract with towards the whole universe in a given country. That's why rejecting is easier, because we are projecting in the end anyway. And we also care about the coverage, both not to allow our patients to be re-identified, but also to make sure that you're getting statistically correct information about the medical or the health condition of the patients in a given region and finally in a given country. What's tied to the ownership is the fact that each supplier has their own model. So you can imagine that if we sign a contract with one practice, second practice, third practice, each time we will get the data in a totally different model, in a totally different format. That's given, that's something we need to deal with. Unfortunately, the only the only authority that has the power to standardize this is the government, because no one else can tell all the practices you need to use that software versus that software. We can give some kind of standard plugins to those applications. Nevertheless, it will never be 100% that everyone needs to comply. To make sure everyone around the country will comply to the same unified standard of medical data, there needs to be international laws that will regulate it. So the input format is different. It's the different feeds, so both the names of those feeds, the file formats, so some of them will be sending us CSVs, sometimes it will be JSON, sometimes it will be a simple text file. So it varies a lot, and it will also be different data type formats. So some of them will be sending us, I don't know, a date with a year, month, day. Some of them will give it with hyphens, with slashes, etc. Right? All those flavors, I don't know, dots or commas as the decimal separators, etc. So that's also given. We'll be getting the data in multiple dimensions. I was showing to you before the variety of the data. That's all, let's say, all this data, all those dimensions I was mentioning, they come in one single package. So obviously, if it's JSON, all that data will come as a single JSON with, okay, here are your lab tests, here is your diagnosis, here is your prescription, here is something else. That's, for, by the way, for that patient, for that doctor, and it's that visit, right? So in a JSON format, you can imagine this can be somehow collated together. Imagine the same in a CSV, right? So a CSV is typically just a tabular form, like an Excel spreadsheet. Then you would have an Excel spreadsheet with many tabs in it. Or individual CSVs, and then you need to somehow aggregate them together at the reception time. It's a different security approach. So some of them will be encrypted, some of them won't be. Sometimes, especially when the direct database access is included, there will be various ways of authenticating to that systems. So just a username and password, that's a simple thing, but think about a two-factor authentication, or think about some other regulations. Well, two-factor authentication was introduced because of GDPR, but now how do the systems connect using the two-factor authentication, right? That's another level of complexity added. And as I mentioned, different sharing mechanisms. So direct databases, that's separate layer of problems. Even detecting a delta, so what has changed on the supplier side, becomes a troublesome when they are sending just giving you a database link and telling you, okay, take data from here, as opposed to giving you the simple files, either on our FTP or on their own FTP, that we get the delta, let's say, given. And the last thing about the data supplier agreements are the changes. So I mentioned briefly the change detection on the database. So we need to, on our own, to be able to establish what is the delta, what has changed within the data that the supplier was providing to us yesterday versus today. But we also need to concentrate on something that many of us developers don't really remember about. That is, we often concentrate on a happy path. That whenever you receive a file from a supplier, you would just need to ingest it into your system. That's it, another file will come tomorrow. As long as this process has completed without an error, that's a good thing. It is, and normally it does, but unfortunately the data suppliers are more creative in here, and they may tell you, you know what, we made a mistake, or we have just reloaded all the data for a given practice. So yes, you've been loading that for half a year, but now please drop all the data you received and try to reload it from scratch. It's called like a rebulking process. So we need to make sure our processes are capable of the data resupply and of the data removal. The data removal is especially important in the situation when the patient wants to opt out. And this opting out from these studies is also something that's very specific and unique to the healthcare data, because in the healthcare industry, following again GDPR rules, the patient has the right to opt out from your studies. So at any given point in time, you've been loading his data since half a year, he may come to you and say, I don't want you to use my data for your studies. And we need to obey it, and we need to remove, or at least logically remove, his data from our system. So the correction mechanisms are important. And finally, sometimes the format of the data that we are receiving also changes. So we have some contracts signed with our suppliers, and technically, based on that contract, it should be a stable thing that you get this 13 CSVs, this is the shape of this data that you will be receiving. But as usually, this format changes, sometimes less expectedly, sometimes more expectedly, and we need to adjust our systems to that. Now I have a question that actually doesn't have a good answer for, but at the same time, it doesn't have a bad answer. So we had a very hot discussion recently. What would you do with such variety of suppliers? We came up with two options. We basically said, okay, you can transform all the various formats into one single input format and then have a standard loading process for that. That was one option. The second option was, do not transform it to a common format, but rather create some plugins for each format seen, and let's say standardize on the warehouse side. So the question was more or less like, do you want a standard set of data on the warehouse, or do you want to push it further? Do you want a standard set of files on an input? So if the supplier is just not compliant and is sending a different format, transform it into your preferred. Would you have some other approach to that? Do you see any third option?
So the standard approach for the warehouse would be to collect all the data and then push only those that are relevant for you right now. So in the case like some other data that are relevant there, you can process further in the future, but for now only processing only part of the data, only one that are relevant for you. So you can skip all those that are not relevant for you. So this would be my strategy for those data.
But would you rather standardize them to a common format that is removing this part of the data that's not standard, or would you rather load it into the warehouse, just the portion that's common within the warehouse?
Yeah, I would only load the portion that is relevant for me. So if I have for example reporting that I am using only 3-4 columns, yes, I'm only loading those part, but still keeping all the data in some raw format, in the archive glacier for AWS or something like that.
So load into the warehouse the part that is common and leave everything else in the supplier files.
Something that is not relevant for me right now. Yeah.
Okay. We also thank you very much. So you can take a cup after maybe the speech. We also thought this way. Unfortunately, quite often our local offices who are purchasing that data tell us, you know what, we are paying a couple of $1 million or a couple of $100,000 for this type of data, and it specifically contains the attributes you typically don't process. Can you extend? And it always happens like in a given country. There could be very specific cases for each country because our law also internationally for the healthcare is different. And therefore, the amount of data being processed in each country is different. And if somebody is paying for that data, he really doesn't want you to strip out some of it because he's paying for the full set. So, yeah, but we were also considering that. Any other opinions here? Okay, if not, then I would like to encourage you to vote, let's say, because I want still to, let's see, you to take a vote in our discussion. So how much of people would think about, okay, we will be transforming to a common input format, so to the standard file, and then loading in the standard file? Please raise your hand. Okay, around 5-6 voices. And creating the plugins for each of the formats seen? Like 7, 8, 9 maybe. Okay, thank you. So yeah, the second option would win. Okay, the last point that I mentioned is around the data dictionary ownership and generally about the variety in the data dictionaries. But before we dive into the dictionaries, maybe I should explain what you are seeing here on the screen. So let's imagine that you receive the data from a supplier A and from a supplier B. This data differs, as you can see. They have different coding standards. They will be using different drug descriptions because every one of them has their own dictionary. They differently tell us about the diagnosis, the practices, etc. The data that we receive, we are trying to map to the dictionaries. There are some dictionaries that are international, like the RX norm, that's a product dictionary, international product dictionary. There is an ATC, anatomical therapeutical classification of the drugs as well. There is an ICD, international classification for diagnosis, and the SNOMED. So again, a diagnosis type of dictionary. So these are given and published every couple of months, every year. There is a refresh of this data. It's being managed internationally. Then there are some country local dictionaries, like a British National Formulary, which is only available in UK, and it also represents a classification of the products. Then there would be our own IQVIA-wide dictionary, so our classification of products. We have this particular system implemented in more than 100 countries, so we have a pretty standard definition of the product within IQVIA. There is a OneKey and MIBOS systems. They are both about practices. There is even a call center within IQVIA that's actually calling all the doctors and gathering the information. Where do they work? What kind of specialties they have, what kind of specialties will they gain in a year time, etc. So we've got a pretty comprehensive OneKey database containing all this information about both practices and the doctors. There is also a MIBOS, that's a system, internal system for collecting information about all our suppliers. That's why you can see all this data here is already linked to the supplier information, because any practice giving us the data needs to be registered within our MIBOS system. And finally, there could be some team-owned standards. So, for example, there is no common dictionary for the gender or for a payment type or for any other small so-called lookups that may exist within the data. Now, this data is already linked, as I said. The practice is in MIBOS, and then maybe the supplier is already using ICD version 10. So we are linking that already to an ICD dictionary. But what about everything else, right? So what if there is a customer that comes to us and says, you know what, I would like to analyze this country data, but I would like you to use the SNOMED codes, not the ICD codes. So it's still a diagnosis, but it's a different dictionary. So what do we do about it? So first of all, our data, because we are using standardizing to our dictionaries, our dictionaries are already linked to some other dictionaries. So if we provide a linking scheme to our products, a linking scheme to our practices and doctors, and a linking scheme to, I think to ICD, right? Then for free, we are immediately getting a connection to the ATC. If we did it to MeBoss, we get a connection to the OneKey, right, etc. So all this is interconnected. But what if it's not interconnected? What if we don't have this? Let's say if between one and the other classification, there is a many-to-many relationship. So it's not like just about linking one attribute here to one attribute there, but actually one here fits many here and one here fits many on the other side. So then the linking is not trivial, and we need to reestablish that linking by providing additional bridging processes. So we need to bridge that data, bridge those descriptions, and tell, okay, now you know this Panadol, 500 milligrams, it's 12 oral tablets, that actually fits into the RX norm, acetaminophen, 500 milligrams oral tablet. Somebody needs to manually bridge it. And that's also something that IQVIA performs on this data. We are providing standard set of dictionaries, and we are linking all the incoming data towards the standard dictionaries. So, to summarize, I started my presentation with briefly listing out all the challenges surrounding big data processing. We talked about the scale, we talked about the knowledge, we talked about the cost, that it's harder to predict and it's variable in time. We talked about the integration of the data, that it's also fairly complex when we talk about big data. And we were talking a bit about the data quality, how hard it is actually both to test the data and how to deal with the constantly changing data. On the other hand, I was trying to explain the complexities resulting from the healthcare industry. So the multidimensional aspect of our data, the various industry regulations which are affecting the way we are processing this data, the supplier agreements we have, it's both around the complex data ownership, the variety of our formats, and I mentioned to you those non-HIPAA solutions that we need to implement. And finally, I mentioned about the various data dictionaries, which are owned by different entities, some of them internationally, some of them in a given country, and some of them internally within IQVIA, and the complexity in the interoperability between those dictionaries. In the middle of that sits IQVIA data as a unified, standardized, and statistically representative medical data for analytics. If you're interested in getting to know how exactly we are dealing with all these data complexities and how to approach this and how to make it a robust and working system, feel free to apply. And thank you for having me today. My name is Piotr Kaczor, and I'm very happy to be your host today. And finally, the questions here.
So I have a more technology-related question. What would be a database system of choice for a health-related data warehouse, considering all these specific requirements, specifically in data governance relating to healthcare compliance requirements?
Okay, it's a very good question. So, as typically on the big data market, right, these days we are using Cloudera stack for this, but we are also looking at the, let's say, more modern data warehousing technologies like Databricks/Snowflake, which both have their advantages on the market, and depending on the use case, probably more like Databricks for the ingestion, Snowflake for the BI aspects of the data. Both of them seem very interesting.
And I do have another one. And regarding this re-identification assessment that you mentioned, is this more of, I would say, a good practice, or is this something that directly comes from some specific industry requirements and has to be done in some specific way?
So the necessity for having the assessment, I guess, comes from the law or from the auditor perspective. But nevertheless, we need to do a pretty comprehensive study of that. Basically, we have a team of analytics that are, let's say, receiving the anonymized data and are trying very hard to uncover the identity of a patient based on that. So it's like bulletproofing the solution just in case someone else gets access to this data.
So I got 3 questions, and I will ask them one at a time. So
Yes,
my
thank
first
you.
question is that during clinical trials, I gave a consent, but you mentioned that my data can be acquired in other ways on one of the first slides. So I wanted to clarify, is it possible that my data can be collected in not so obvious way, so I don't give a consent?
It's a good question, but these days actually all the data hits the medical systems, right? And it depends on how the law is constructed. I'm aware that within the British society, they are already having a chance to say for which purposes they are allowing their data to be used. So formally, even within our country, you should be asked that question whenever you're giving it to a given system to say, what is it that you allow the system to process the data for?
And I wanted to ask, how do you remove the anonymized data when the patient opts out?
What?
When you've got anonymized data in your database, and
How do I remove it? Yeah, because it's following the same anonymization technique as before, right? So it's not that the patient is directly contacting IQVIA, he's actually contacting our data suppliers, and the data suppliers are giving us anonymized data. They use the same anonymization technique on this patient opt-out information as they do on a regular patient. So it's coming through the same source, right?
Okay, so that also answers my third question. So when you purchase the data, do you bear responsibility when your data seller fails to inform you about the patient opting out? So it's all on them in that case?
In that case, it's all on them. Yes, that's true.
Okay, thank you very much.
Nevertheless, yeah, thank you for the question. Nevertheless, we are not trusting entirely our suppliers, and we do this due diligence anyway, just to check if the data cannot be re-identifiable.
I have a question about how do you define what is a wrong data for your set, or is it more like some invalid data, like you know that it's more like, I don't know, female operation on male or something like that, or maybe you know that this prescription wasn't bought or something like that?
That depends from where we are sourcing the data. As I said, IQVIA is a very large company, so we get the data from various sources. Obviously, when we get the data from a doctor's office, we only know about the prescribed drug, and that's the only thing we know about. But at the same time, we know that it was given to a patient diagnosed with that, that also has made this kind of lab tests and reported this kind of problems. So it's a more rich information. It's a bit hard to correlate that data with the data from the pharmacies, where as opposed to that, we get an information about the drug that was prescribed and the drug that was purchased by the client himself, what was the price, which insurers, for example, gave a discount to this procedure, etc. So it's a kind of different type of data. And again, here correlating that would depend. I think we are not running such projects these days to correlate that data somehow.
So it's not sure if that person
has bought the
take the test, for example, from the laboratory, or
it would require, like a separate study would need to be performed on the patients which have this kind of drug, let's say, prescribed, whether they really purchased those drugs. And if they purchased it, what was the drug given to them? Because sometimes we are changing the drug. I don't know, the pharmacist says, this drug is not available, but I can give you something in exchange. And then, yeah, we get to know what this exchange is.
And do you count it as your some kind of błąd pomiaru in Polish?
Okay, like measurement error, right, or something. Yes, well, we need to take it into account, right? So it's an important information from where did we get the data. By the way, sometimes the government is sharing this kind of information. I don't know if everyone here realizes, but in UK, the GMC, it's like an or NHS, that's the same as our NFZ. They actually published the medical information from their general practitioners on the website, open source. Obviously, it's anonymized, etc., but it's linked to some of the dictionaries. You can do some analytics on top of it. So sometimes it's also the government sharing the data to us, either through public channels or through other channels if we sign a contract for analytics.
Okay, thank you.
I would like to ask if the regulations and contracts you need to comply with impose any requirements on the durability of the data. So if they do, how do you approach challenges related to it?
Well, yes, they do, because we can store the data for a certain amount of time, right? But really, I don't know, from a database perspective, it's just about simply dropping the data older than X years, right? So there is nothing complex. Same for the files that we receive. We can actually keep dropping the data after usually 10 or 15 years of keeping it.
I was a bit more interested in the data loss protection, for instance. Do you need to do it or not really? So, for example, if you lose some record, is it a problem for you from the, let's say, regulatory perspective, or not really?
No, from a regulatory perspective, that's not a problem. That's just affecting our statistical correctness of the data in the end. Yeah.
Okay, thanks.
Yeah, thank you. And please come over here in the end. Okay. I think the time is up now, so we can finish here. So thank you again, everyone.